Hey guys, it's been a while, hasn't it? So today I want to show you how you can handle file upload in Actix Web. For that there are two crates we could use. There's the Actix Easy Multipart crate and the Actix Multipart crate, which is being developed by the or provided by the Actix Web team. I haven't yet used the Easy Multipart crate, so I don't know what makes it so much more easier than the Actix Multipart crate, because I think it's already easy enough, and I'm going to show you why and how you can use it. So if some of you guys maybe have used the Easy Multipart crate, you might enlighten me and the viewers why this is so much better and why this is so easy. But let's get started. I've already created a bare bones Actix web server, and the dependency are as followed in here. I'm going to explain then as we go on this tutorial why this is why those dependencies are important, why we're going to need them. So the first thing is we're going to need to import the multipart extractor. And this one is fairly easy, done like that. And now we can work on the upload function. So the first argument we're going to need is the payload, which has to be mutable because it implements the asynchronous stream. So we're going to loop over the stream and trying to get the next value by that also consuming the payload and altering the payload and making it mutable, so it has to be mutable. And so it's of type multipart, obviously. We also gonna need the request because we're gonna need some information about of the request so we can handle some things. What things do we want to handle? So let's brainstorm about it. So the first thing we are going to need or we want to do is limit file size. The next one would be limit the file count. We don't want the user to upload 500 pictures at once. And we also want to, if we have a function request where, for example, we have embedded images inside a message, or we are posting vacation photos of our vacation. So then we also want to handle the logic of uploading more than one file. So we want to limit the file size, file count, and also write our code to be able to save more than one file at once. Yeah, we want to limit the file type. So we, if this upload function in this case is, we only want to upload pictures. We don't want to upload movies or a text file. Only pictures are allowed. And the next one would be save the file. This one will be temporary because we also want to convert that into a GIF, for example. And I know some of you guys are triggered that I'm pronouncing it as GIF. It is GIF. It's just the way I pronounce it. Just deal with it. It's okay. It's okay. So yeah, because a GIF is smaller in footprint and we want to resize it, maybe make it a little bit smaller, or maybe if the picture is too small, we want to make it a little bit bigger. So this one is might be as well a step that you want to take when creating a web server of yourself. So and now that we've done that, so the first thing is going to limit the file size. We can get the file size from the contact length inside the request. So we can gonna call request.headers. This is going to return a headers map. And on that we can call get and then content.length. And this get function is returning an option. So if it's some header value, then we are going to try to cast that into a string. And if this one fails, we're gonna replace that, or we're gonna set that into a string of just the number 0. And then we're gonna try to pass that into a usize because we know this won't fail. We are gonna pass that into usize. If it's none, then let's just return 0. So this one should be comma, not a colon. So yeah. Now the contact length, we got the contact length. I think, maybe correct me, but the contact length cannot ever be 0. Like it has to be some value because we are sending some JSON or some header that, like it can't be 0. And if it's 0, then we want, then something failed. So the content length is none. So we don't really know how big the payload really is. Someone might have tampered with the request headers. So let's not deal with that request. So if content length is 0, or if content length is bigger than the max file size. So if that's the case, then return HTTP response bad request and turn that in. It's just a empty bad request. That's all that we need for this case, for this video. So delete max file size, define it as well. Let's say it's just 10 megabytes. So the next one, it's already done with checking the content length inside the headers. This one might not be 100% safe, but it's the most simplest way of limiting the file size. Maybe someone might be tampering with the content length and setting the header or changing the header to a smaller number and then uploading a whole movie, or I don't know. So there might be some better ways, but this one is the most simplest way without going over the top. And yeah, now the file count. Max file count is also usize, and let's say only 3 files are allowed. So for that, we're also going to create the variable called current count. That's going to keep track on which number we are on, like how many files we are already we have already saved and which file we are currently on. So this one is usize and it's starting by 0. And for that, we're creating a custom loop. So to begin with, if the current count, the first check is if the current count is bigger or equal than the max file count, then we are going to break out of it. And at the end of the loop, we are going to add 1 to the current count. Like that. So, and if the loop has been done, we are going to HTTP response, okay. And just into. We don't need a body. Don't need a comma as well. So now we can start with accessing the file inside the payload. For that, we can call payload try next. This one is from the asynchronous stream trait, as I said before, and asynchronous means we have to await that. And the next function, there's also a next function that's going to return an option. The try next function is basically returning option wrapped inside a result. So to check that, maybe let's say if let some other way around, okay, and then some, and then let's say this is a field, and if this one is okay, we can access this field. Then this means we have a payload, that we can do something, like we have a field inside the payload. If this one is not, like it failed, that means that we've consumed everything inside the payload. So we can safely break out of the loop because there's nothing more that we can do. We can call try next again and again and nothing changes, so we don't. If it changes once, that means there's no payload, there's no field to access anymore. So now we have to check the file type. So to get the file type out of the field, we have to call field.contentType. And this one is returning an option of MIME. So MIME, what is MIME? It's basically describing what kind of file type we are dealing with. So if you ever created a web server, Nginx or Apache, you might have used MIME or added some MIME types that weren't supported by default by those servers. I don't know, but MIME is basically describing, is it a text file, is it a PDF, is it a, like whatever. file type there is outside of the word. So we need to import that as well inside the MIME crate, and we're gonna need some more. So to check if this one is one of those files that I'm importing here as a image JPEG, what's also GIF. So let's create a legal file types array where we define everything that we want to allow in this case. So this one is of type MIME, it has the size of 3, and it's all those I imported before. So image dot yes. And if this file type now we've got the file type inside the field. So this one might be none because it's optional. So if file type is none, then we don't really know what type we are dealing with. So let's just continue and go into the next field. Yeah, is that right? Okay, let's do that. So, but if the file type is not inside the legal file type, that means it's a legal file type, it's a text file or any other then we are going to continue as well. So for that, we are just calling, we unwrap that and pass it as a reference. And yeah, if it's not inside there, continue. I don't care about it. So the last thing you might need, if I've already created a website, basic HTML file with some JavaScript code that's going to handle the file upload for us, the client-side file upload. And I've already created here a form with 3 different file inputs. And we're going to take those file inputs and then make a request with Axios where we pass in the form data that we've created here. And as you can see, I've named them something. Like I've given all those fields a name, and I've named them upload. Maybe you have many fields with many different pictures, and you want to handle them accordingly. Like, I don't know if that's even possible, but maybe let's say that's the case. Then we don't want to access the first one, which is called uploads. Like, I don't care about that. We just care about upload. So so let's do that as well, where we check the name of the field. And this one is fairly easy. We just call field.name. And if this does not equal upload, then continue as well. And because we're also checking the file type, as you have seen here as well, this one is not a file. This one is just a string called test. And this one in the request is going to be of file type text. I think so. But nonetheless, even if it's not, let's say if it's text, or if it's something, if it's not even defined in the content type, we're gonna skip that. We don't gonna care about that. We don't gonna treat this test as an image and therefore breaking our server. We just skip one. We will skip this one and we go to the next one. That's the first file we're gonna save. It's the second, that's the third, and then it's going to break. It's going to stop. Because we've said in our function that we'll only allow 3 files, 3 images, and if it's any other than an image, then we don't care, we go and look for the next image. Yeah, so everything is done. So now we can save the file. So for that, we can also call file.tryNext and file field.tryNext, and this one is trying to get the value, get the war string, the bytecodes of the image, the payload, or more particular in this case, inside the field, which is one file, we try to access the value, the file. So, or you could say chunk, because tryNext is also returning, as before, something wrapped inside a result. We're gonna do that like that. We also need to await, and in this case, we're gonna say while. So we just get a chunk. It might not be the whole file. We just get one chunk of the file and then looping over those chunks and saving that into a file. But I didn't import, for being able to call try_next, we also need to import the trait. This is inside the futures util, and it's called try_stream extension. And just like that, we have imported it, and then the compiler won't complain that it doesn't know what try_next is. So we want to save this file. So we have to create the file in Rust before. So let's call it saved file, and this one is file system file and create, and we have to give that a destination. We're also going to create as a variable because we want to access them more than once. So let's call destination, it's of type string, and format. So step by step. So at first we need to add the directory, the path where we want to store the file. Then we're gonna create some random string, some random UUID to make sure that we don't overwrite an existing file. And then we are going to add the original name of the file that's being uploaded. This one we need to do because later, I'm going to explain that later why we need to do that, because the file extension is important for the image crate, that we're going to need to convert the image. So the correct file extension has to be the one that we are trying to save the file onto our server's file system. It's a bit complicated, but we are creating a temporary file. With that temporary file that we saved on our server, we're then going to convert it into some other file. So to get the file name, it's inside content disposition dot what's called, I don't know. Content disposition get file name. And then we unwrap that. Yeah. So the directory is the first one, then the UUID, then we say a minus, and then we're gonna add the original file name. So we make sure that the file extension, if it's a PNG, a JPEG, or any other than that, is correct. So yes, actually you could also do like a check if the file type is a JPEG, make it just like PNG or JPEG, depending on whatever MIME type it is. This might be even better. Because I don't know, maybe some reason the file type, the file extension is not added in there. There's some like Linux doesn't really care about the file extension. So there might be some loophole in here, but let's just leave that like that, and I'm gonna update in my private project to make it more secure. But there you know, you might even make this code even better than it is right now. And yes, so we are creating the file. We have to await that because we're using the Tokyo asynchronous library for that. And then just like normal FS, we unwrap that. So let's import Tokyo FS, and let's also import from the IO the asynchronous write extension, because when we're trying to save the file, we're gonna need this extension. If we don't import the trait, the compiler won't know that this function exists on the field or on the variable we're trying to do that. So in this case, we have the chunk and we're saving it. So saved file.write all, and pass in the chunk. we await that, and then we unwrap that. And because this one is returning a result, we're gonna create this placeholder variable so the compiler won't complain. You don't use consume result in a correct way. So that's why I'm doing that. So saving the file, and that's it. The file is now saved in that destination. So the next thing is we're going to need is to convert that file into a GIF. So for that, I'm going to use block inside Actix Web. So Actix Web, basically. What have I done? This one is in Actix Web block. Did I import it here? Yes, I imported in here. So sorry for that. Let's go back to the code. So I'm going to use web block because converting the image crate is not asynchronous, it's synchronous. So Actix Web has this really neat block function which takes any snippet of code and puts it inside another thread that is available inside the thread pool that's providing under the hood Tokyo. So in the last video, I don't know, maybe in the JWT video, I said that Actix Web is built upon the Actix framework. That is not correct anymore. Since a long time, it's actually built on top of Tokyo, but you might already know this. I didn't know that for 1 or 2 months ago. I'm sorry for that, for the fake news. But yes, web block allows us to take synchronous or asynchronous code that might be blocking and put it inside another thread. So this thread that's currently working on handling those requests is not being blocked. This is important because converting the image might take some seconds. And those seconds means that the request can't handle any other requests that are coming in. They have to wait. So that's not what we want. So we can just pass that inside another thread, basically. So let's create updated image or converted image. Let's say updated image. And this one is just using the image crate, open, and then we pass the destination in here. And no await, just unwrap. And yeah, this one is of type dynamic image from the image crate. So import that as well. Image dot dynamic image. Yes. Do we need something other than that? No, not yet. Later. Updated image. Oh yeah, before we gonna convert the image. Now that we've loaded the image inside this updated image, it's now stored in RAM. So we don't need the original temporary image file, we can delete it now. So let's delete this one. It's also returning, what did I say? It's also returning a result, so we pass it into a temporary placeholder variable, so the compiler won't complain. What's called the function? It's fs remove file, am I right? Yes. So destination, and then we await that. So using Tokyo and unwrap that, because that's how you use the fs remove file function. So now the original file is deleted, we don't need that anymore, we try to convert it, and we're gonna resize that into exact 200 times 200. You can change that if you want that. And we also have to give that a filter type. And for that, let's take the nearest. Yeah, I'm gonna show you. There are different filter types provided by the image crate. So let's look up filter here inside the image ops, and there you can see different algorithms we can use. I use the nearest, it's the ugliest one. Maybe you want to use triangle or this one here, but the nearest is taking only 30 milliseconds. It says here it's using this CPU and this image, so the times vary, but nearest is the fastest one, and then triangle takes up to 4 seconds. So depending on what kind of image you're dealing with and how fast you want it to be and what kind of quality you want it to be, you can use one of those algorithms to do that, or filter types. This one was inside image ops, and yeah, filter type. So then we're going to save that inside a new destination. So let's create a new destination, and for that we are going to need a directory. We are going to need a new UUID, and that's it. Let's make a little bit size. We can do that. So here we're also passing the directory, the new name, which is just a random UUID .gif, and this is all we're gonna need. The image crate knows, because we've named that GIF, that this one is going to be converted into a GIF, and it knows because of destination it's ending on PNG, JPEG, or any other. Then it's going to need, okay, it's going to be converted from a PNG to a GIF, and that's it. And it's doing all of that behind the scenes with us, without us worrying about anything. And that's it. That's basically done. But this code won't compile for now. Compile for now, because yeah, we are taking ownership of the destination in this anonymous function. So we are also calling async await. So we have to make this asynchronous, but we also have to add one more move in here. Why is that the case, you might ask? Rust doesn't have asynchronous closures, I think they meant. Is their name in English? And anonymous functions. So this one is not legal. This one won't compile. This one will, because it's basically the same as saying, well, we don't have to need this move, having an asynchronous block in here, but instead of creating a new block, we are just saying, okay, the first block is already asynchronous. And for that, we need, the closure needs the move keyword because it's taking ownership. And because we're creating a new closure in here, new with this parentheses, with this async keyword, we need to have another move to let the compiler know, okay, not only is this anonymous function taking ownership of destination, but the asynchronous block is also taking the ownership. This is necessary. In the future, this won't be necessary anymore, because the Rust team is actively trying to make really good async await features, and they are working really hard. But for now, this is what we have to do to make the code compile. And yeah, so this is on one side, but we also need to add something here. We want to await that because the block function is returning a future. Need to await. Then because this future, after it has been awaited, is returning a result, that might return an error. In this case, we expect there to be no errors because our code has to be 100% bulletproof, and I don't expect there to be an error. If so, please panic and let me know as a developer there's something wrong. But in your code, you might want to change that. So await, unwrap, and then because we have another asynchronous in here, we have to await that as well. And that's everything we have done. The file has been saved as a temporary, has been converted into a GIF, and that's it. Return, okay, it's done. Let's see if that compiles. Did I forget something? Yeah, I forgot something. Yes, I forgot UUID and the directory and a semicolon. Oops, this one is wrong. It's inside here. So at first let's import UUID. And the dir variable, which is an SDR, and it's just inside upload. And then there was a missing semicolon in here. So cannot borrow is mutable. Oh yes, oh yes, oh yes, oh yes. Why did I go to the wrong tab as well? So where was it? Where the field is? No. Where the payload is. It's away. Where do we have the field? I can't find it. One is the field, this one. Okay. Save, oh, saved file. Yes, saved file has to be mutable because we want to write to that file. So yeah. Now it compiles. And it says unused result that must be used. Unused result that might be used. Why do you? Oh yes, the save one has to be unwrapped, because this one is returning a result. So like that, and we don't have to return that. So I guess returning that is not a really big problem. But yes, now it works. Either way, so the server is compiling, and I've already created the website that we're going to use to upload the image. I've shown you as well, no? the index.html in here. So let's go and test that. And let's do it like that, so we can see if the file has been uploaded. It's inside this directory. Inside the directory upload. So let's make that directory, and now it has no files at all, but let's upload a file. Let's upload a black pixel. And we got a 404 back. Why is that the case? Oh, yeah. Yeah, we're gonna have to need upload here as well. So yes, that was not really good. Now that so we compile that, and now the upload will work. 100%. Trust me, it's going to work right now. And it worked. So let's see if the file has been uploaded. Not in here. Where's the file? Oh, yes, the file has been saved, but you have to add the slash here as well. Because now the file, if you go one directory up, it's called just upload, and yeah. It's working. It's working really good. Let's clear that one, recompile that, and now, trust me, now it should work. But you've seen now that we could upload a file, but with some minor bug. So, let's see. Now we have the file here, and we can upload many files. And many files have been saved to the server without a problem. And you can test that. We can make 100 uploads, and everything works without a problem. And then we have all those files. Let's remove all those files. And as you can see, inside the index.html, this one here, the first one, the test, is being completely ignored. It's not a file. It's yeah, it's not a picture. It's not legal. It's just some text. So this one is getting skipped without a problem. And this one is really awesome. It's really easy to make, safe and robust yeah, file uploader functions inside Actix Web. And yeah, we can add 2 pictures. Let's also add a red pixel in here and also the white pixel. And let's go back into here and remove everything. So now the directory is empty, and upload all 3 files, and we can see all 3 files have been saved. Let's open our file manager, and you can see those are the pixels saved as a GIF. And if we open that in an image, we can see where the image properties, it's 200 times 200. Everything works as you would expect it. Everything is awesome. But before you're gonna go and implement that for yourself, I want to show you what kind of awesome way, like I've created an uploader struct, or yeah, you can call it struct object, where it's making all of this in a really, really nice syntax. Instead of writing this code for every function, I'm going to show you in my project in Bubble server Rust, which is the Rust version of the Bubble project I'm working on. And I've created here the an uploader, which is just a struct with all those fields, and it's creating, you can call new. For example, if I have this, where is it, inside users, and then update avatar. And then you can see for the handler function, I have just this one match, like create a new, set the field name, set the upload directory I want to save the file, what kind of name I want the file to be. And then in the save function, I'm passing the payload and request, and it's going to do the whole thing that we've written and does everything, saving the file, converting the file, and at the end, it's going to return a response, and we can return a request to the client like needed. So in here I have all those functions that override those values, and the save extension here I've written with the asynchronous trait allows us to make us asynchronous implementations or traits. And in here I have this whole basically this whole function that we've written, but a little bit more verbose or more versatile in that sense. So you can check that out on my GitLab if you are interested in that. It's gitlab.com mark m. and Bubble server but Rust at the end. So in there I have the code inside. Where is it? In source, utils, and upload. And then you can get your inspiration. Yeah, I hope that helps you. I hope you learned something today. And thank you for watching. Maybe like and or dislike the video. Make a comment what you liked about, what you want to see next. And we're gonna see you next video. Bye.